look at this coupler now because it is going to be used in your MZI. So your MZI has two couplers. So this is my coupler 1, this is my coupler 2, and at this end I have two detectors. So what happens is I have coupler 1, the same setup, A, B are input arms, C and D are output arms. I am not using arm B at all. From arm A, I am sending in a light wave of input I. So just like we saw, I will get I by 2 on the arm C with same phase, I by 2 on the arm B which is 90 degree out of phase. And this is what is going to travel all the way up to E and F. Now let's not look at the words reference arm and measuring environment. We'll come back to those later. So this I by 2 which is in the same phase travels through CE, and the I by 2 which is 90 degree out of phase travels to DF. Okay, so now what do we have at EF? Now we need to note that EF are both input arms for the second coupler. So what are the inputs the second coupler is getting? Firstly, it is getting an input of I by 2 from E which is at the same phase meaning zero phase difference, and another I by 2 from F which has a 90 degree phase difference. So all of these inputs will be split up and sent across G and H. So we will see how that split up happens. So first we take the I by 2 which is coming from E. That will be split into I by 4 which goes to G and I by 4 which goes to H. So this I by 4 is going to be same phase as I. So it is 0 degree phase difference. So from A to C and again from E to G, it did not cross over at any point. So I by 4 with phase equal to 0. And then from E to H, you will have I by 4 with a phase difference of 90. Why 90? At this point it did not cross over, but from E to H it crossed over. So one crossover, so 90 degree phase difference. So whatever input I got from E, I have divided it into two parts. Part 1 is of intensity I by 4 and its phase is 0. Part 2 is of intensity I by 4 and its phase is 90. So the part 1 is at G, part 2 is at H. That is about what input I got from E. Okay, we move on to the input we got from F. So what did we get from F? We got an input of I by 2 which was already 90 degree out of phase. Because of the crossover from A to D, our input here is already 90 degree out of phase. Now this I by 2 will again be split into I by 4 which travels to both the arms. Now if you take the I by 4 which goes along G, you see that it came from A to D which was a 90 degree phase switch, and again from F to G is another crossover, so another 90 degree phase switch. So 190 degree phase change with respect to the input. And when you look at FH, there was a crossover from A to D, so there is already a 90 degree phase change, but from F to H there is no phase change. So you get an I by 4 here which is 90 degree out of phase. So to quickly summarize, what do we have here? At G you have I by 4 with 0 phase which came through the path A, C, E, G, and you also have I by 4 which is 180 degrees out of phase which came through the path A, D, F, G, two crossovers. At H you have I by 4 which is 90 degree out of phase because of A, C, E, H, one crossover, and you have another I by 4 which is also 90 degree out of phase because of A, D, F, H, this crossover. So if you look back to G, we said we have one thing which is at 0 phase and the other which is at 180 degree phase difference, meaning they cancel each other out. So essentially what you have at G is 0, and here both are at 90 degree phase change, meaning both have the same phase, so they add up. This I by 4 and I by 4 add up, so finally the intensity here will be I by 2. This is how a normal Mach Zender interferometer works. Quick recap, I give an input of I here, it gets split into I by 2 same phase, I by 2 with phase 90. This again splits to I by 2 phase 0, I by 4 phase 0, I by 4 phase 90. This one again splits into I 4 phase 90 and I by which has a phase 180 degrees. So this 0 and 180 they cancel each other out. So here I have 0 degrees phase, 0 intensity. At detector 2 the 90 and 90 add up, so I have an intensity of 180 degrees. This is a basic Mach Zender interferometer. I mean, this is its basic mechanism.